All right, let's go ahead and start working on this. If we're asked to simplify or multiply out this polynomial expression up here, what the heck are we going to do first? Separate out the 2x plus 1 squared into two sets of the 2x plus 1 is a absolutely wonderful and probably very wise decision. To take that 2x plus 1 squared and rewrite it as 2x plus 1 times 2x plus 1. It's a lot easier to do that multiplication written out like this than to square it in your head unless you are absolutely 100% used to it. I'm just going to scoot that up just a smidge. So rewriting our square like this will make this easier to get right by a long shot. Just saying. Rewriting it like this, so much easier to get correct than trying to manually do it in your head. Multiplying out the top one, which it's not giving me a laser pointer on. It's decided to freeze on me now. It loves to do that. Ooh. What are we going to do next? Yeah, we're going to pick a pair of factors, really, because I have, 1, 2, 3 factors here. I'm going to pick a pair of factors to multiply together. It is a lot easier to do these in pairs than to try and do all three at the same time, because honestly, keeping organized when it's all three at the same time is nearly impossible. Even in my own work, if I'm working on my grad school stuff, I won't do three at the same time. Not going to happen. It is almost impossible to get correct. So I'm going to take and just do two at a time. So I'm going to look at these first two. It genuinely does not matter which two you do first. If you want to do a 2x plus 1 and an x plus 3, totally valid. Does not matter which ones you do first, but only pick two and go from there. When we're multiplying these together, I can use box method. I can use double distribution. I can use FOIL. I could use a whole lot of options for how to do this. I'm going to go ahead and do my distribution. Where I'm going to take my 2x times 2x. And that's going to give us a 4x squared. I'm going to have my 2x times 1. And that's going to give us a 2x. I'm going to have my 1 times 2x, which gives us another 2x. And then we have our 1 times 1, which is a 1. Once we get here, what do we need to do? Combine some like terms. I do have some like terms in here. What we have here is I have my 4x squared. And then I can combine together my 2x and my 2x to get 4x's plus 1. And this is what that 2x plus 1 squared really comes out to be. So if you did this without rewriting out your 2x plus 1 squared as two separate factors, this is what you should have gotten. If you got 4x squared plus 1, you're not having it right. But now we've multiplied those two pieces together. That's that purple bracket at the bottom. And now I need to bring down the fact that we only looked at these first two pieces. I still need this guy. He's still a part of it. I have to multiply all of these together. When we do that, we're going to get to do a whole nother round of multiplication. I'm going to move that down a smidge so I have a little bit more space. because we're not done. I want to multiply this out entirely, which means I need to do a whole nother round of distribution, or another box, or a gargantua foilapalooza. But we need to multiply these again. So I need to take everything in this first set of fractions, or the first set of terms, and multiply it into my second set of terms. So my 4x squared needs to multiply against both of these, my 4x needs to multiply against both of these, and my 1 needs to multiply against both of these. So we're going to do all that multiplication, whole bunch of it. 4x squared times x is going to give us a 4x cubed. And we're going to take our 4x squared times 3. And that's going to give us a 12x squared. Then we're going to do our 4x times both those pieces. So 4x times x gives us a 4x squared. And 4x times 3 gives us a 12x. And one more set. I need to take my 1 times the x, so we get a plus 1x, or just plus x. And our 1 times 3, which gives us a 3. When we multiply out our 3 times 2 things, we should get 5 whole terms. Or 6 whole terms. Goodness, I'm so good. I have 3 here times 2 things here, and I want to have 1, 2, 3, 4, 5, 6 terms. Now we need to combine our like terms together, because we do have 2 pairs of like terms in here. So our final answer on this, our fully simplified, multiplied out version of this polynomial, we got our 4x cubed. I need to combine together my 12x squared and my 4x squared. 12 plus 4 gives us 16. My 12x plus x, we've got 13 x's plus 3. And that is our full and complete answer. Questions on that one? Okay. We are going to be on page 18. This is the bottom one on page 18, number 3. And we are looking to divide these. So we are trying to divide this whole polynomial, my x cubed minus x squared minus 25x plus 25, dividing it by x minus 1. And we've seen problems written like this before. We saw those, not yesterday, but on Friday, where we had them written with this division symbol and the factor. If we were going to do long division, we could just straight up hop in and go from here. I could put this one inside the house, and my x minus 1 out here, and go from there. But that is really, really long, and I would much rather use synthetic division if we can, because it's so much faster. But in order for us to do synthetic division, I need not the factor, because in long division we use our factor to divide. I need to know what the root is. What is the root of this factor? One. It's a positive 1. Because what we do to find that, just as a quick reminder, that's when we take our whole factor, that x minus 1, and we set it equal to 0. We add 1 to both sides, x equals 1. That 1, the positive 1, is what we're going to divide by using our synthetic division. Long division, we use the factor. I'd put that whole x minus 1 outside. When we're using our synthetic division, I need the root. So when we're setting up our synthetic division, I'm going to put, in my little box goes that 1. And the numbers as we go across are the coefficients from in here. So we need to have our 1 from in front of the x cubed, minus 1 from in front of the x squared, minus 25 from in front of the x, and plus 25 in the very end. We skip a line, draw a line. So leave yourself a little bit of space between your number and the total line there. Questions on that setup? Okay. So then what we're going to do is we're going to use our process for synthetic division here. Our first term always just straight up falls. Every single time. 1. Boop. And then I'm going to take the bottom times the left and put it under. So I'm going to take my 1 times my 1 and put it under here. Well, 1 times 1 gives us 1. And then we need to add negative 1 plus 1. What's negative 1 plus 1? 0. We get a 0 down here. It's okay. It's allowed to happen. We keep on going. 0 times 1, 0. So underneath the negative 25, we're going to put that 0. And then we still add. So we're going to add our negative 25 plus 0. We get negative 25. Well, negative 25 times 1 gives us a negative 25. And when we add those together, negative 25 plus 25, we get a 0. Our very last term on the bottom is always, 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 always our remainder. So this guy is not a part of our answer next. This is going to be just a number. This one goes with our x's. This one goes with our x squared. So it always is going to count up like that. From the right to the left, it's our remainder, our number, or our constant, then x's, then x squareds. It is always going to have a remainder at the end here. You can either start and do it the way that I did, with our remainder, number, x, and x squared, or you can go down 1 degree. It's always going to go down 1. So our x cubed turned into an x squared. So that's the other way you can go through that. So let's write out our remaining polynomial here so we can see what is going on. So we have our 1x squared plus 0 x's minus 25. Well, we don't typically write something if we have 0 of them, so I'm going to come up here. And I'm going to write this instead of 1x squared plus 0x minus 25. I'm just going to put our x squared minus 25. And again, if we wanted to be able to check our work and I wanted to like undo this division, I could take my x squared minus 25 and multiply it back by the factor we divided by, the x minus 1. Is there any more factoring we can do? Like, could I simplify this more? Yeah. How is this going to factor more? What's this going to be? It is one of our special patterns. Yes. You can also take this and do it the old school way where we find our pair of numbers that multiplies to make negative 25 and adds to make 0. It's not square root. What pair of numbers will multiply to make negative 25 and add to make 0? 5 and negative 5. This one is our difference of squares. It's one of those special patterns. You can do this old school. I could take and run this through factoring by grouping, bottoms up, split the middle. But when we have something that comes out of our synthetic division that is factorable, we want to factor it. So I could factor this to be my x plus 5 with that positive 5 and my x minus 5. So I know every factor of this polynomial. This times that gives me that original polynomial we started with. So our factors are the results that we got, are x plus 5, x minus 5, as well as the thing we divided by, our x minus 1. When we're looking for the roots, we already know one of them too. One of the roots for this polynomial is the one we used in our synthetic division, that positive 1. To find our roots for the other factors, we can do the exact same thing we did for our divisor, where I take my x plus 5 and set that equal to 0, and I need to take my x minus 5 and set that equal to 0. So what are the other two roots we get for this function? What is the solution, doesn't it, for these two? If x plus 5 equals 0, what does x equal? Minus 5. We subtract 5 from both sides, we get minus 5. So here x equals minus 5. What's up? Yes. Because it was silent when I asked us what the roots were. So if we're not sure, this is how we find it. If we can do it in our head, great. Love it. Fantastic. If we're not sure, that's how we find it. Okay. Questions on this one? Cool. All right, so we're going to flip to page 19. We're going to look at 4. So we are asked to find all the factors in the roots of 2x cubed plus 5x squared minus 9x minus 18 when we know one of the factors is x plus 3. So they're giving us that information. So again, if you want to do long division, that's totally fine and it'll work. It's just significantly longer. But if we know a factor, that means we also know a root, and I don't have to do long division. I can take the shortcut way, which is our synthetic division. So what we're going to do is we're going to take our x plus 3, and we're going to find our root. What is our root for this factor? Negative 3. It's that opposite sign when we have a single linear factor. So when it's just x plus something or x minus something. If we're not sure, take your whole factor, set it equal to 0. Easy peasy. When we're setting up our synthetic division, that root is what goes in the corner. Taking our whole division and flipped it on its head, so it's a little division house, goes upside down around our root. And then I take my coefficients, my numbers from across my problem in order. So I have my 2 for my x cubed. I have my 5 for my x squared. My minus 9x minus 18. Skip a line, draw a line, and we are set up. First term is going to drop for us. So we've got our 2. Then we take the bottom times the left and put it under. So 2 times negative 3 gives us a negative 6. There it is. When we add those together, we get a negative 1. Negative 1 times negative 3 is going to give us a positive 3. When we add those together, we get a negative 6. Oh, different shade of color. Negative 6. Negative 6 times negative 3 gives us a positive 18. And then our negative 18 plus positive 18 gives us a 0. Questions on that bit? Okay, let's write our polynomial that's left over and see if we can go any further. So this guy over here at the end, that's our remainder. This one's a number. This one gets our x. This one gets our x squared. So I can rewrite this polynomial as our 2x squared minus 1x minus 6. So can we factor that more? Can we simplify this even further? Yeah, sure can. This is when we're going to need a tool to do this. Because we have an a value, we have a number in front of our x squared, we need to use some sort of tool. Box, factoring by grouping, split the middle, bottoms up, whatever you want to do. But we need some sort of tool to be able to factor this when there's an a value in front. We can factor this because we have our a times c. That's going to be 2 times negative 6. We get negative 12. And our b is negative 1. We need a pair of numbers that multiplies to make 12 and adds to make negative 1. What pair of numbers is going to multiply to make negative 12 and add to make negative 1? I say I'm definitely with you on the 3 and 4, but which one of them is going to be negative? Negative 4. I'm going to go ahead and do the box up here. Just because I know it's been a minute since I did a box up here. You can use whatever technique you like. If you would like to do a split the middle, bottoms up, grouping, whatever option you like for factoring, totally valid. I'm going to do the box. So our 2x squared always is going to go in this top left box, our ax squared term. Our c term is always going to go in that bottom right box. And it's these two numbers, our 3 and our minus 4, with this middle variable that go in these other two boxes. It genuinely does not matter which one you put in which box. But I need to get my 3x in one of these boxes, and I need my 4x. Oop, minus 4x in a box. Got the minus side. I'm going to make it fit better. There we go. And then when we're trying to find our factors, we're going to pull them out in columns and rows. So I'm going to do these rows. So the greatest common factor, what's being shared between 2x squared and 3x? Well, that's just an x. They both have x's, but that's the only number they have. And in my bottom row, between minus 4x and minus 6, they both have a factor of 2, and this box is negative. So I'm going to take the minus sign out here. That bottom spot will always have the same sign as that first box. So if this box is negative, this spot will always be negative. If this spot was negative, so would this guy. So these two share a sign, and these two share a hello. See if you can find the other factor. Bierschke. I think that would probably be a good fit. Mm-hmm. Right. Okay. What do we think might be the other factor over here? What's shared between 2x squared and 4x? Definitely an x. And a 2. We need to be able to factor, guys. Our second column over here between our 3x and our minus 6, we get a 3. So our factored form of this quadratic alone, we've got our x minus 2, and we've got our 2x plus 3. Our final factor for this polynomial is the one we divided by, our x plus 3. So that's still a part of it. And that's our full factor form here. So it's basically undoing a multiplication very much like the one we did in the bell work. So our last bit here is finding the roots, 2 of which we'll be able to do probably fairly simply, 1 of which it might require us to write it down. We already know one of them because we divided by one of them. So this guy we already know the root for, our x plus 3. That was the minus 3 that we put in the box for our synthetic division. What is the root for x minus 2? Positive 2, yes. When in doubt, set it equal to 0 and solve it, which is probably what we're going to have to do for this one. It is absolutely doable in your head, but we just got to be super duper careful. If we want to know what the root is for our 2x plus 3, whenever there's that number in front of the x, it's always a little bit harder because our answer will be fraction. You don't have to get all the way down to an x equals on here. Once you spot it, I'm totally cool with that. You don't have to show every line of every step you take. So when we're solving this, we're going to get our 2x equals minus 3. So what does our x equal? What is our root? Negative 3 over 2. You do not have to switch it into a decimal. You can leave it as minus 3 over 2. You could also put it as negative 1.5. You could also put it as negative 1.5. They all are just exactly the same. That's the exact same amount of correct. Questions on this one? Yes, sir.
How do you know where it's like 2x squared minus 1? How do you know when you keep going after that?
This is pretty much our sure way to check and see if it's factorable. If I can find a pair of numbers here, we are good to go. If I cannot find a pair of numbers that will multiply to make the top and add to be the bottom, it's not going to factor.
Yeah, but I mean, you knew before you were less than.
Because I did it before. So, because I have done so many factoring problems, I can see the patterns in them. And that's one of those things, the more times we do factoring, the more we're going to know, oh, this is probably going to factor. Let's double check here. But even if I didn't know for sure it was going to factor, this is how we would test. We would take our a times c and multiply them together. We'd take our b and put it on the bottom and see if I could find a pair of numbers that multiplies to be the top and adds to be the bottom. That is the test for, is it going to factor? Our only other option to get solutions, if that wouldn't factor, would be if we use the quadratic formula, and whole, if it won't factor, we would just write this. And that would be our solution. Okay, I want to do one more today, and then we'll finish things up and kind of bounce around and kind of fill in some spots on the notes packet tomorrow. I want us to look at this next one, because we haven't seen any that didn't come out nicely yet. Oh, snap. So this one also has that weird notation where we've got the whole 2x cubed plus 3x squared minus 50x minus 75 times x minus 2 to the power of minus 1. Remember that those negative exponents mean that's a flip. So this is the same thing as saying times 1 over x minus 2, which is the exact same thing as dividing by x minus 2. So it's just a weird way of writing the problem. So when we see it written like this, it doesn't mean anything different. It still means divide by that guy. So again, I could use long division. Totally fine. Absolutely works. Just long division is long, and I don't wanna. Synthetic division is easier and faster. It's just a little bit tricksy to remember sometimes. But when we're using synthetic division, I need my root, not my factor. So what is our root for this x minus 2 term? When in doubt, if we don't know it, set your factor equal to 0. X minus 2 equals 0, which means that our x equals, add 2 to both sides, 2. So our root is positive 2. So when we're going to try and set up our synthetic division here, positive 2 is what goes over here on the side. Then what we're going to do is we're going to grab all our coefficients, the same way we've always done. So we're going to have our 2x cubed plus 3x squared minus 50x minus 75. And we're going to see what happens when we do this synthetic division. Got a whole process to work. So we're going to go ahead and drop this 2. And we're ready to start. Any questions on the setup bit? All right. Bottom times the left and put it under. So we're going to 2 times 2 is going to give us a 4. And then we add 3 plus 4. It's going to give us a 7. Bottom times the left, put it under. 7 times 2 going to give us a 14. And then we're going to add. So we're going to take our negative 50 plus 14, giving us negative 36. And we take our negative 36 times our 2, and we get negative 72. And when we add those together, what do we get? Negative 147. Ew. We didn't get a 0 in our remainder spot. So we're going to see how we would write that. When we do not get a 0 here, we do not have to worry about not factoring. This guy is giving us a remainder. So that means we have found the end of the problem, and we're just going to have to write it down. We're still going to have our number and our x and our x squared. So all those pieces are still the exact same things. So we're going to write this as our 2x squared plus our 7x minus 36. And then we have this remainder. And we worked with this when we did our long division with numbers, where we had our remainder of 1, and then we had divided by 3, so we wrote it as 1/3. So what we're going to do is we're going to take our remainder, that minus 147, and we're going to put that 147 as the numerator of a fraction. 147. And what goes on the bottom is what we divided by. However, that's not a 2. There are no letters in this problem. We did not divide by 2. What we divided by was x minus 2. So when we have a remainder, we're going to take whatever that remainder number is as our numerator, and our denominator is going to be the factor that we divided by. So we're going to write this as x minus 2. So our quotient is that 2x squared plus 7x minus 36 minus our remainder of 147 over x minus 2. So if we have remainders left over, we write it as a fraction over the factor. We will practice some more with this tomorrow. We've got at least one more problem in there. We'll probably bounce back and catch a couple of the kind of like random ones that we skipped, because our chapter test is coming up on Friday. So I will have the chapter review for you guys tomorrow. We'll finish out any questions we've got in the notes packet. We'll work a couple more examples. We'll have some time to work on homework and ask questions, and we'll go from there. So we have about 3 minutes to the end of the period. Homework 4 isn't due until tomorrow, so we have a little bit more time to work on it. The back side has the synthetic division on it. Just be really, really careful. If you get a remainder, we're writing it as a fraction.